Okay, so, yeah, I just did a little thing on people using a calculator to do this. That's ridiculous. Okay? Maybe not ridiculous considering that you've had a calculator in your hand since you were 4 years old and never learned to use your head. Or you did for a while and then started going to the calculator when you didn't need to. Now we're going to get a matrix here that you would want to use a calculator to square because the arithmetic gets way too complicated. I don't expect you to be able to multiply double-digit numbers at least over 20 and know those multiplication tables and know how to do it. You need that in order to be able to think through problems, think through approximations, visualize the numbers, visualize the quantities, visualize the relationships. That's where it starts, by doing arithmetic in your head and on paper to an extent. Okay? Now actually, you know, squaring 0.83 on paper, yeah, you should be able to do that. You should understand why that algorithm works. But in reality, you're probably not going to do much of that. Okay? You should be able to, but you know, at this point, go ahead and use the machinery, right? Okay, so 0.9, 0.2 multiplied by 0.9, 0.1. Now, most of you are writing out the details. That's in the dots, right? And you did it right, okay? A couple of people got things in the wrong place, but they got that straight. Okay, so everybody's doing real well with this. Okay, so I'm just going to point it out. 0.9, 0.2 times 0.9, 0.1 means 0.9 times 0.9. What's 9 times 9?
81.
So what's 0.9 times 0.9? 0.81. How ridiculous is it that you use a calculator to do that calculation? It's totally absurd. Okay? Even if you have had a calculator in your hand for the last 48 years. Okay? Yeah, some of you are that old, aren't you? Okay, well, no. Okay, so that's 0.81. And then you're going to add 0.2 times 0.1, which is what? 0.02, right?
Mm-hmm.
I mean, you're taking a tenth of 0.2. You're not going to get 0.2. You're going to get 0.02, right? And you need to think that through. You know, these are things that people don't think through because they use a calculator when they shouldn't. Okay? So you add up 0.81 and 0.02. What do you get?
0.83.
Oh, I thought it was 2.83. No. And I could do that, but you won't. Okay, so that adds up to 0.83. It's a very simple calculation, right? Okay. 0.9 times 0.2 is 0.18. 0.2 times 0.8 is 0.16, and that adds up to 0.34. Okay? You should not have to write any of that down, although it's not a bad idea to check yourself. Okay? And then 0.1 times 0.9 is 0.09. 0.08 adds up to 0.17. And 0.1 times 0.2 is 0.02. 0.8 times 0.8 is 0.64. You add that up and you get 0.66. Right? Okay? Now, a couple of things that I'll observe about these matrices. In a minute, we're going to square this one. And if you're trying to do it in your head, if you can do it in your head, I'm impressed. Okay? And if you do it on paper, well, that takes too long. That's where you're going to need to use a calculator, and that's totally appropriate. So you got to, if you need the calculator, use it, but if you don't need it, and if you're not sure you need it, don't use the blame thing. Okay? Think. Use your brain. Okay, well, before we square this, let's note something. This and this add up to what?
1.
The first column here adds up to
1.
1. Very good. You did that in your head? Yeah. Nobody reached for their calculator. I'm happy. Okay, so you're learning already. What's this add up to?
1.
Oh, man. What's this add up to?
1.
What's this add up to?
1.
Getting monotonous, right? Columns will always add up to 1. Which means you can kind of shortcut the calculations. If you get this number, you know what this one's going to be. Or if you can subtract from 1, you do, right?
Yeah.
But don't do that because you want to check for inconsistencies. If it doesn't add up to 1 after you've actually done it, then you got to debug it because it's going to bite you, right? I expect things to be checked and I expect them to be done accurately. And y'all are very good at that. Okay? So let's go ahead and square this one.